Now we are in week 9 part 1b video. We're still under chapter 3, which is coordinate system, but we want to go to more interesting topic, which is now we want to plot polar curve. So the first shape that we want to plot here is a circle. Next, we go to the cardioid, limason, and porosus. Polar curve refer to a technique of sketching some elementary curve, in which in this topic we will focus on how to plot or how to sketch circle, cardioids, limason, and porosus. There are two techniques here, which are plotting polar, that is, we plot a polar coordinate, and then we also can convert polar equation to Cartesian equation. So we start here to plot circle in polar coordinate. Circle is given by general equation of r equal to a cos theta and also r equal to a sin theta. A here is referred to diameter of the circle, and half of this a will refer to the radius of the circle. To understand circle in polar coordinate, let's say we have here our general equation r equal to a cos theta. So how to plot this circle, it depends on the value of a. For example, when a greater than 0 means that a is positive value, we will have the circle on polar coordinate will be on positive side, which is given by this circle. It is like a positive side of x. So here a is actually is a diameter of the circle, and the radius of the circle is given by 1 over 2a. If we have a less than 0 means that our a is negative value. So we will have here a circle on a negative side of x, means that you will have this circle where the diameter of the circle is given by a, and then we will have here 1 over 2a as a radius of this circle. If we see previously, for r equal to a cos theta, the circle is on x-axis, either on positive or negative side. But if let's say we have here r equal to a sin theta, when a is greater than 0, so our graph is a circle which is on positive side of y-axis. In this case, the diameter of the circle here is given by a, and the radius here is given by 1 over 2a. Then, if a is negative value, so the graph for this circle will be on negative side on y-axis. Means that here the diameter of this circle is a, and the radius here is 1 over 2a. Go to this example 1. The question asks us to sketch the polar curve r equal to 3. So class, for this example, understood the radius of this circle is 3 and there is no cos or sin theta. Means that this is a circle with radius r equal to 3 and center at origin. So we will have here the circle which is center at origin. For this x is 3, here negative 3, and then y 3, this one negative 3. Instead, we will have this kind of circle. Now we go to this example 2. The question asks us to sketch the polar curve r equal to 2 sin theta. So now, in general, we have a formulation of r equal to a sin theta. First, in this case, we need to check the value of a. A is equal to 2, which is greater than 0. And our function here is a sin theta, means that in general, we will have a circle on positive side of y-axis. So, for this case, when a equal to 2, which is greater than 0, our circle will have a diameter equal to 2. And the radius here, which is radius, will be equal to 1 over 2 times a, so equal to 1 over 2 times 2 equal to 1. When we plot here, we will have this one as 2 means that the diameter starting from this origin to this point is 2, and then here for this x will be -1 and 1. So we will have here this kind of circle. Then we go to this example 3. The question asks us to sketch the polar curve r equal to 3 cos theta. In this case, we have r equal to 3 cos theta means that this is cos function. So our circle will be at x-axis, something like this. Now we want to check a value which is equal to 3 and it is greater than 0, so it is on positive side of x-axis. And then our radius here, which is radius equal to 1 over 2a, so equal to 1 over 2 times 3, which is 1.5. In this case, when we plot here, we will have, for this a equal to 3, means that the diameter of the circle 1, 2, 3, means that 3 is somewhere here. Remember, it is on x-axis. And then for y-axis, we will have here 1.5 and -1.5. When we plot here, we will have this kind of circle. Then we go to example 4. The question asks us to sketch the polar curve r equal to -4 sine theta. Now the difference here, we have negative function. So we have here r equal to -4 sine theta. And when we know that this is sine theta, means that our circle should be on negative y-axis because here it is -4. Here our a is equal to -4, which is less than 0. And then our radius here will be equal to 1 over 2 times -4, which is -2. But this one should be in, because it is distance, should be in absolute value, so it is 2. So when we plot here, we will have for x-axis 2, -2, and then for y-axis, the diameter of the circle is -4. When we plot here, we will got this kind of circle. Then we go to the last example, which is now we want to sketch the polar curve r equal to -6 cos theta. In this case, our a is equal to -6, and then our radius should be equal to 1 over 2 times -6, that is -3. In this case, we have cos function. So, in general, when we have cos, it should be on x-axis, but because this a is negative, so on negative side, it is something like this. When we plot here, we will have the diameter here is -6, means that somewhere should be here -6. And then for y-axis, 3 unit above and 3 unit below, so we will have this kind of circle. The last question asks us to sketch the polar curve r equal to 3 cos theta in GeoGebra. So how to do this? This is GeoGebra link, and then you need to input your function here, which is r equal to 3 cos theta, and then automatically the output function will be appear here. But if we see here now, we have a diameter 3 consistent with this, and then the radius here is 1.5. Now it comes to the end of sketching circle in polar coordinate. Next, we will go how can we sketch for cardioid in polar coordinate. Thank you and see you in the next video.